The first technological tool that I will use to support student learning is Pear Deck. Right here is the home website once you log in. That is Pear Deck. It's going to support the activity that we are doing in math because students will be able to create and share their answers. They will explore different ways to split up fractions while creating wholes and breaking them into parts. This will support constructionist principles because students are exploring how to break up wholes into pieces by drawing, by manipulating images, by creating fractions, and by sharing and looking at responses. It will enable differentiated instruction because I'll be able to walk around and assist students as needed while they are formulating answers. I'm also able to assign them different fractions or slides or things to do using different assorted tools based on their abilities. So here's the home screen. You can create a lesson right through here if you wanted to. It creates it in a Google Slides file, but then eventually, so make your lesson interactive with Pear Deck. Eventually, it'll be a Google Slides, and this is how you're presenting it. So this is the particular Google Slides that I will use for this lesson plan, and this is about equal sharing in relation to fractions. This is just an example. I just created this equal sharing in fractions one. I haven't done it yet. But when you do get student response, student feedback, this is kind of what it looks like. So this is an example of a Pear Deck that I have done in the past. And students can draw on it, and then you're able to show their responses. So if there's one you really like, or if you want to show the different thinking, so how this kid jumped on a number line, how this student marked 1/8 each time, you're able to do that. You can lock their screens, or for differentiation purposes, you can give a new prompt as well. And that's Pear Deck. So the second technological tool I will use is online manipulatives. So these are the online manipulatives. They are on a website called Toy Theater, and there's so many different manipulatives. The ones in particular that I will be using are fraction circles and fraction strips. It will help support the activity that we're doing because students will be exposed to the manipulatives and they're able to compare them using this online tool. It will promote constructionist principles because students will be building fractions on their own and recording their results in a Google Slides. They will need to create meaning for each fraction and apply that meaning to their work. So this is meaningful work that they're doing. And this activity allows for differentiation because students can be assigned different fractions, different manipulatives. So if fraction strips are easier, or if fraction circles are better suited for this. In this case, I'm going to use fraction strips. And so if they're comparing or benchmarking to a half, they're going to pull 1/2 here. And if the fraction is like 2/12, then they can drag and they can easily see, 2/12 is less than 1/2. And then this is where they can record their results. And then if they wanted to use manipulatives that were hands-on, they could use that as well. But I'm going to strongly encourage the use of the online fraction strips. And the last technological tool is just Google Slides that I will be using. Most of these have Google Slides, but the Google Slides have other components. So for this last part, I'm focusing primarily on Google Slides and what it allows me to put in the presentation. Google Slides are great if students are creating something or for problem solving. So students will use Google Slides for both of these things. Students will create their own slideshow about equivalent fractions, displaying their knowledge, and then they will also problem solve by solving different problems on a set of slides. So for the creation of Google Slides, they would need to go to their Google Classroom, and there would just be a blank template for them to complete, and there would be directions on the slide for them to do and follow. But they are creating a slideshow based on equivalent fractions and what they've learned in the lesson. When on a different lesson, they have a video embedded here to help them remember the equivalent fractions rule, and then they have different problems that they can solve to figure out if it's equivalent, yes or no, to create number models for equivalent fractions, and to match equivalent fractions, and all these different tools are being utilized here. The creation of slideshows allow for differentiation because students will have different guidelines based on skill level. So most students will be able to use different tools, but some will use images, some utilize text-to-speech, audio clips, they'll be able to talk and place that in their slideshow, and videos. Both activities promote the use of constructionist principles because they are creating something, they're problem solving, and all this has real world application, and they will be able to work with their math peers on this as well.